Welcome to lesson 2. You can think of the fluency as your warm-up. This choral response means that we're going to say it out loud together when I give you the signal. So if we were in class, you would raise your hand when you knew the answer, and then you would wait for my cue to say the answer aloud with your classmates. The question is, what value is represented on the chart? You're going to say the answer in unit form. Then we would count 1, 2, 3, and you would say 110. So 110 is equal to blank ones. Say your answer out loud on the count of 3. 1, 2, 3. 10 ones. You can see the disc unbundled as 10 ones on the chart. Here is the next problem. What value is represented? This is 110 and 2 ones. What would go in the blank? Provide your answer on the count of 3. 1, 2, 3. 12 ones. We can unbundle the 10 to create 10. Mixed with those 2 makes 12 ones. What would be provided in the blank here? 100 is equal to blank tenths. On the count of 3. 1, 2, 3. 10 tenths. You can see it's unbundled to create 10 tenths. What value is provided here? This is 1/100 and 4 tens. So what would go in the blank? 1, 2, 3. 14 tens. 100 is unbundled to make 10 tens. With the extra 4 that were already there, 14 tens. Next, this is 1,000. 1,000 is equal to how many hundreds? Provide your answer on the count of 3. 1, 2, 3. Next, 1,500 is equal to blank hundreds. 1, 2, 3. 1,500. 1,000 is 10 hundreds, and there were already 5 hundreds. One 10,000 is equal to 1, 2, 3. 10 thousands. And last one, we have 1 10,000 and 7 thousands. How many thousands would that be? Are you ready? 1, 2, 3. 17 thousands. Oh, I was mistaken. There's more than one left. Here I have 100,000. We're going to speed through these next ones. Think about your answer and then check if it's correct. One 100,000 and 9 10,000s is how many 10,000s? This next one is a whiteboard exchange. So if you have a whiteboard, you can write your answer down. If we were in class, we would all hold up our whiteboards to check if they were correct. So think about each question. And if you're by yourself, you can just think about it If you're with a group, you can share your answers out loud. So here we have this number, and I'm going to read the number shown. This is 48,359. What digit is in the 10,000s place? The 4. So what value does that represent? If it's 4 10,000s, that would represent 40,000. We're going to write this in expanded form. I'm going to give you some time to think about it. You can think back to the previous lesson. If the 4 is in the 10,000s place, and that represents 40,000, then the next place value is an 8 in the thousands place. Then we have a 3 in the hundreds place, a 5 in the tens place, and a 9 in the ones place. Take a moment to write it in expanded form, or think about what that would look like. This is how we would write the number in expanded form. 40,000 plus 8,000 plus 300 plus 50 plus 9. It may be helpful to have a place value chart out in front of you. We used one in lesson 1 that you can flip back to if you need to. What digit is in the thousands place? 3 is in the thousands place. Write this number in expanded form. If you have a whiteboard, you can write it down and then check your work when I display the correct answer, or you can think about what it would look like. Are you ready? If not, pause here and take as much time as you need. Here it is in expanded form. Notice the 0 here would be in the hundreds place. So we don't have any hundreds. We skip from the thousands to the tens. We don't have to write 0 hundreds. We can just leave it out. Here's the next one. What digit is in the 100,000s place? The 2. This time, there are 2 digits that have a 0. So we don't need any 10,000s, and we don't need any tens. Your addition sentence is going to have 1, 2, 3, 4 pieces to it. Again, use that place value chart if you need to, and take as much time as you need. When you're ready, we can check our work. 1, 2, 3. 200,000. 7 is in the thousands place. 9 is in the hundreds. And 3 is in the ones. How about this one? What digit is in the 10,000s place? 6. Take the time to write it in expanded form, or think about what it would look like in expanded form. Keep in mind, we do not need any thousands or any hundreds. You can use that place value chart if you need additional support. Are you ready? 1, 2, 3. 700,000, 60,000, 50, and 1. Tara has 54 nails in her toolbox. She needs 100 times as many nails to build a treehouse. How many nails does she need? If you're with a group, go ahead and discuss your thinking and attempt to solve this problem. If you're on your own, think about some strategies you might try to solve this question. You can pull up that place value chart and think about how we would shift those digits around when we multiply by 100. You may also think of it as 54 times 100. Or you may know that 100 is made up of 10 times 10. So you could do 54 tens and multiply that answer by 10. Well, 54 times 10 is 540. And then I still have to multiply by another 10. 540 times 10 is 5,400. Now we're going to use mental math to solve problems like this. We're thinking about patterns or looking for patterns to be efficient in solving questions that multiply or divide by tens, hundreds, thousands, and so on. Give numbers 1 through 3 a try. Multiply by 10, then 100, and 1,000. What is 5 times 10, or 5 tens? That's the same as 50. What is 5 times 100, or 5 hundreds? That's just the number 500. How much would 5 times 1,000 be? If 5 is in the thousands place, that would be 5,000. Look for a pattern. What's an easy way you could explain this to someone else? What do you notice? You may recognize that when you multiply by a 10, there is one extra zero at the end of the product. 100 had 2 place values at the end, and 1,000 has 3. So you can think of this as 5 times 1, and then 3 place values after that. 5 times 1 is 5, and then we need 3 extra spots. Like I mentioned, if you need that place value chart, you can find one on page 78 in your workbook. And we're going to use that chart to help us solve problem 4. How many tens is 5 tens times 10? Well, we would have 5 And then we would need 10 times as much. So there's 1, 2 sets. We would need 10 sets of 5 tens. So it's going to look like this. But we can rename that. Instead of saying 50 tens, because that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Instead of saying 50 tens, what's another way that we could state that? Well, 10 tens regroups to make 100. So I can replace 10 tens with 1 in the 100 spot. Another set of 10 tens turns into 100. Continue that process. I can rewrite 50 tens as 1, 2, 3, 4, 5 hundreds. In standard form, 5 hundreds is the number 500. You can sketch this in your place value chart. When you draw dots, bundle and rename to show 10 times as many. Now that's a time-consuming process, so it may be more efficient to watch as I display these. But follow along with me so you recognize the process that's happening. Here is number 5. 50 is 5 tens. When we multiply 5 tens by 10, we can see the units shift. And when we multiply by 10, it gets larger. So here I'm multiplying by 10, and that would result in 5 hundreds. But I'm not multiplying by 10, I'm multiplying by 100. So let's break it down. 100 is 10 times 10. So I took 5 tens, the 50, and I multiplied by 10, but I need to do it one more time. So they shift again. And now I have 5 in the thousands place. So 50 times 100 is 5,000. Let's look at that pattern. 50 times 1 is 50. And then I have 2 extra place values, which you'll see here. A 1,000 is 100 times 10, and we know that 100 is 10 times 10, so 1,000 is 10 times 10 times 10. This problem can be rewritten as 50 times 10 times 10 times 10. Let's look at how this plays out on the place value chart. We would place 5 in the tens column, and then we would transfer or shift those by 3 columns. Here we started with our 50, And then we've shifted 1, 2, 3 times, and we've landed in the 10,000 spot. I have 5 10,000s. Here you can see the 10,000s place, and I need 5 in that place value, which is 50,000. Following that pattern we discussed, you can see 50 times 1 is 50, and then there are 1, 2, 3 extra place values. This one is multiplied by 30. So we need to rewrite that using tens. We have 48. How could I rewrite 30 using tens? This is 3 times 10 gives us 30. So we can write this as 48 times 3 times 10. We'll start with 48 times 3. 3 times 8 is 24. 3 times 4 is 12. Plus 2 is 14. So 48 times 3 is 144. And I still need to multiply by that 10 that's left. Well, that shifts the place value 1 position. So that is 1,440. 144 times 1 is 144 with that extra place value at the end. Here we go. You can see 144. Each piece gets shifted 1 spot when we're multiplying by 10. So that is now 1,440. How would we do this one? Try and break apart 300 into tens. How can the last problem help us solve this one? Well, I know that we just solved 48 times 30 from the previous problem, but this is 48 times 300. To turn 30 into 300, I have to multiply by 10. From the previous problem, we saw that 48 times 30 was 1,440. I need that answer times 10, which shifts the place value 1 spot. So I need an additional 0. This is 14,400. You can see that instead of shifting once, for 300 it needed to shift twice. Here was our answer from the previous problem, and we needed to shift it 1 extra time. So we have 1 in the 10,000 spot. 4 in the thousands, and 4 in the hundreds position. How would we solve this one after doing problem 7 and problem 8? $3,000 is just one extra shift from 300. In the previous problem, we had 48 times 300, but this is 3,000. So I need to multiply by 10 to turn 300 into 3,000. In problem 8, we solved this piece, and we found that 48 times 300 was 14,400, and I still need to multiply by the 10, which moves that place value one more spot. So instead of 2 zeros, I now need 3 zeros. 144,000. Here you can see the answer to problem 7, then problem 8, and now we have the answer to problem 9. The 1 is in the hundred thousands position. Number 10 uses division instead of multiplication. How does the process change when we divide by 10 rather than multiply by 10? When you divide by 10, the number gets smaller. So instead of our pieces getting shifted to the left to get bigger in our place value chart, they need to shift to the right to make them smaller. The 2 is in the hundred thousands position. Oops. And the 7 is in the 10,000s position. So when we divide by 10, we need to shift them. So now I have 2 in the 10,000s position and 7 in the thousands spot. So 2, then a 7, and then zeros. You can think of this as shifting the place values. There were 4 zeros, and now there are only 3. So dividing by 10 moves you backwards a place value, makes it smaller. This one is very similar, but instead of dividing by 10, we're dividing by 100. So we have 270,000 divided by, we can break it up just like we did before. 10 and 10 make that 100. So we had 2 here and 7 here. And we divided by 10. So now I have 2 here and 7 here. But then I need to divide by another 10. So the 2 is in the thousands place. and the 7 is in the hundreds place. What would happen if instead we divided by 1,000? Well, 1,000 is 10 and 10 and 10. So this is 270,000 divided by 10, 10, and 10. This was the one from the previous problem where we divided by 100. And now I have an additional 10 that I'm breaking it into. So I'm moving to make it smaller. So the 2 is here, and the 7 is here. So I have 270. Here in problem 13, we have 270,000 divided by 30. Is this similar or different from 270,000 divided by 10? Well, 270,000 is the same, but now we're dividing by 30, not 10. We do know that 30 is 3 times 10, or you can write it as 10 times 3. So we're going to rewrite this as 270,000 divided by 10 times 3. We're rewriting 30 as 10 times 3. We can do it either way, 3 times 10 or 10 times 3 for 30, since multiplication is commutative. But it's probably going to be easier to divide by the tens first, because we already did those in the previous problems 10 through 12. So we're going to use that fact to help us find this answer. What this means is 270,000 divided by 10 and then divided by 3 as well. We have to divide by 30, so we have to divide by the 10 and the 3 that make up the 30. Well, from problem 10, we know that this piece is 27,000. So I need 27,000 divided by 3. Do you know what 27 divided by 3 is? I know that 3 times 9 makes 27. So this is 9, but it wasn't 27, it was 27,000. So 27,000 divided by 3 is 9,000. I can use that to help me with the next few problems. Number 14, 270,000 divided by 300. Well, 300 is 100 times 3. And we know that 100 is 10 and 10. Back in problem 11, we did this calculation. It shifted 2 place values backwards to make it 2,700. And then I need to divide that by 3. We know 27 divided by 3 is 9, but it has 2 extra zeros, so 2,700 divided by 3 is 900. We have 270,000 divided by 3,000. 3,000 is 1,000 times 3, and 1,000 is 10, 10, and 10. In problem 12, we did this, and we ended up with 270. So I need 270 divided by 3. 27 divided by 3 is 9. With that extra 0 means our answer should say 90. We're going to close this lesson with a debrief. It says, Sana says 450 divided by 50 is equivalent to 450 divided by 10, 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 because 50 is 5 tenths. Do you agree? I disagree. If 50 is 5 tenths, then it should be a 10 and a 5, not more tens. If you had that many tens, you would be 10, 100, 1,000, 10,000, 100,000. You would be doing 450 divided by 100,000. And that is not the same as dividing by 50. How is multiplying by 10, 100, and 1,000 similar or different from dividing by 10, 100, and 1,000? Well, when we're multiplying, we get larger, so our place values shift to the left to make the number larger. And when we're dividing, we're getting smaller, so our place values have to shift to the right to make the number smaller. How does multiplying or dividing by 100 or 1,000 relate to multiplying by dividing by 10? Well, it's just multiple tens, so you have to do that process repeatedly. You also have a problem set to try, so make sure you attempt some problems from the problem set, just to check your understanding. How well did you get today's lesson?